Hello again. It's time for lesson 3.3, solving inequalities using multiplication and division. Okay, so basically when we first start this off, it's going to be the same thing. You solve it the same way you'd solve an equation, just like the addition and subtraction ones. You'll see there's a little bit of a difference when we're trying to multiply or divide by a negative number, but just hang on. So the multiplication and division properties of inequality state that if you multiply and divide each side of an inequality by the same positive number, the inequality stays true. So that's what's got your back. Those properties allow you to do what we're about to do. So the first one, I have 3x is less than or equal to negative 24. Yep, we're going to solve it the same way. I would divide each side by 3 so that I'm left with 1x, which is just plain old x. And I'm going to bring down my symbol, and negative 24 divided by 3, yes, that is negative 8. So x is less than or equal to negative 8. Go ahead and do a quick sketch of a graph. Negative 8 will be in the center, negative 9 to the left, negative 7 to the right. If x is less than or equal to, I'm going to use a closed circle because it means it can be that amount. And I'm going to shade to the left because less than is left. All right. Letter B, negative 18 is greater than 1.5x. I'll draw my line. I want to get rid of this 1.5 that's being multiplied by x, so that means I have to divide by 1.5. So x is still on this side. I'm going to bring down my symbol. And when you take negative 18 divided by 1.5, you get negative 12. And I can't take it written like that with the x on the right. Oh, so I'm going to write the x on the left. And it's pointing at the x, saying, haha, I'm more than you. Make sure it's still pointing at the x. So there's our answer. We graph our solutions, negative 12 in the center, negative 13 to the left, negative 11 to the right. X is less than negative 12. It means it can't be negative 12, so I'm going to use an open circle. It can only be the values that are less, so I will shade to the left. All right, here's a division equation. So x is being divided by 8. To undo division, remember that we multiply. So I'll multiply both sides by the same amount. Those 8's end up cross-canceling, so I get x divided by 1, which is just x. Negative 5 times 8 is negative 40, and we bring down our greater than symbol. So x is greater than negative 40. I'm going to write negative 40 in the center. To the left, negative 41. To the right, negative 39. If x is greater than negative 40, it means it can't be negative 40, so I'm going to use an open circle. And I'm going to shade the values to the right. Okay, letter D, this is a division equation. The variable is being divided by 5. To undo that, we're going to multiply each side by 5. So P is left on the right. Ooh, we'll change that soon. And now we're taking negative 6.4 times 5. That actually gives you a negative 32. So right now, P is on the right. I don't like that. I'm going to put it on the left. And it's opened up towards the P. I'm going to make sure when I rewrite it, it's still opened up towards the P. So P is greater than or equal to negative 32. We'll graph that. Negative 32 in the center. Negative 33 goes to the left. Negative 31 to the right. And if P is greater than or equal to negative 32, I'm going to use a closed circle because or equal to means it can be negative 32. So closed circle in that, and then greater than means I'm going to shade to the right. Pretty easy, right? Well, if you're trying to multiply and divide each side by the same negative number, things change a little bit here. So all these words say, if you multiply each side of an inequality by the same negative number, the direction of the inequality symbol has to be reversed in order for the inequality to remain true. So right now, you've learned that we didn't have to switch anything up. And if you think about it, we have used addition, we've used subtraction, and we have used multiplication and division, but we never had to multiply or divide by a negative. All those other ones had positive values that we had to multiply or divide by. So to get you to see kind of why this happens, I have 10 is greater than 2. I wrote it a couple of times because I'm going to use a couple of illustrations here. If I have 10 is greater than 2, we know that that's true. If I add the same number to each side, like let's say I add 2 over here and I add 2 over here, is 12 greater than 4? Yep, it stays true. If I would have subtracted each side by 2, 10 minus 2 would be 8. 2 minus 2 would be 0. Is 8 greater than 0? Yeah. So adding and subtracting the same amount to each side doesn't change anything at all. Same thing here. If I divided each side by 2, 10 divided by 2 is 5, 2 divided by 2 is 1. Is 5 greater than 1? Yup. If I multiply each side by the same positive amount, 10 times 2 is 20. 2 times 2 is 4. Is 20 greater than 4? Yup, so it stays true. Now let's see what happens if I divide each side by a negative 2. If I take 10 divided by negative 2, I get negative 5. If I take 2 divided by negative 2, I get negative 1. Is a negative 5 greater than a negative 1? No, it's not. So it won't work. Same thing, if I multiply by a negative 2, so 10 times negative 2 is negative 20. 2 times negative 2 is negative 4. Is a negative 20 greater than a negative 4? Nope. So multiplying and dividing by a negative number. You're allowed to have negative numbers within your inequality, but if you have to multiply or divide each side by a negative, you have to flip the symbol at the very end of the problem. So let's try a few of these. The first example here, negative 9m is greater than 54. Okay, so I'm going to start off solving this like normal. I would divide by a negative 9. The fact that you just divided by a negative means that instead of this opening up towards the variable term, it's now going to point at it. I have to switch the direction of it. So negative 9 divided by negative 9 is 1. M is left alone, and 54 divided by negative 9 is negative 6. So instead of saying m is greater than negative 6 and bringing down the sign, because you divided by a negative, we have to switch the symbol so that the inequality still remains true. To graph this, I'm sure you're getting quite used to it. Maybe you've already started while I was babbling on. I put negative 6 in the middle, then negative 7 to the left, negative 5 to the right. And if m is less than negative 6, I'm going to use an open circle because it can't be negative 6. And less than means shade to the left. All right, let's try another one. I have 12 is greater than or equal to negative 4/10 y. I'm going to divide by negative 4/10. The fact that we just divided by a negative means that I need to switch the direction of my inequality symbol. So it was pointing at the variable term. Now I need it to open up towards a variable term. And the or equal to part you just bring down. When you take negative 12 and you divide that by 4/10, you get 25. I know it would be pretty amazing if I did that in my head. I actually didn't. I had these done beforehand. Alright, so I don't like the fact that this variable's on the right. I'm going to write it on the left. I'm going to put 25 on the right. And it's opening up to the y. I need it to open up to the y again. So solution to this is y is greater than or equal to 25. I'll write 25 here, and just for fun, I think I'll count by 5s on this number scale. Why not? We can use whatever we want. So if y is greater than or equal to 25, I'm going to use a closed circle because it can be 25 or all the values greater. That means I shade to the right. 2 left. Yay! Almost there. Okay, so p divided by negative 4 is less than 7. In order to undo this dividing by negative 4, that means I need to multiply each side by, yes, a negative 4. As soon as you multiply by a negative, you have to flip that sign. So p is not less than anymore, p is greater than, and 7 times negative 4 is negative 28. So p should be greater than negative 28. I'll draw my line, negative 28 in the center, negative 29 to the left, negative 27 to the right. If p is greater than negative 28, it means it can't be negative 28, but it can be all the values to the right of it, because that's greater. Okay, last but not least, remember when this negative sign is in the middle like that, it means it can go with the top or with the bottom. Since I want x by itself, I'm going to put it with the bottom and get rid of the 5 and the negative sign all in one shot. So we just multiplied by a negative. You guessed it, that means I need to switch the direction of that symbol. So it was opening up to the x, now I want it to point at the x. And say, haha, this side's greater now. And then when you take a negative 5 times a negative 5, you end up getting a positive 25. Again, I really dislike it when the x is on the right side like that. I think people struggle with how we're supposed to graph it and get it all mixed up. So put the x on the left. It's pointing at the x. It still needs to point at the x. So x is less than or equal to 25. Here's my 25. I'll count 24, 26 by ones. So if x is less than or equal to 25, it means it can be 25. And it can also be all the values to the left. Now before you stop, I want you to take a look on this side. The other examples that we did, we didn't change the signs. And there was a negative 24 in this example, right? But when you divided by a positive 3. Just a negative number in the problem doesn't mean you switch it. It's when you multiply or divide by a negative. So this was divided by a positive, the sign stayed the same. This one you're dividing by a positive, the sign stayed the same. This one we multiplied by a positive. It doesn't matter that there was a negative 5 in there. We multiplied by a positive, the sign stayed the same. Multiplied by a positive, sign stayed the same. The difference in the examples over here is that in order to solve it, you have to multiply or divide by a negative value. So we divided by negative 9, switch the sign. We divided by negative 4/10, switch the sign. We multiplied by a negative 4, so we have to switch it. And then we multiplied by a negative 5. So it's only when you're multiplying by a negative that you have to switch the sign. I'll see you tomorrow.